today I'll be going over targets 4 and 5 on how to graph a cube root function, and then on the back side we will be looking on target 5 at the domain and range. So to graph a cube root function, we're going to start here with looking at the parent function. It is the most basic functions that don't have any transformations done to it. So for our cube root function, we can write it with a rational exponent as x to the 1/3, or we can write it as the cube root of x. When we graph the cube root function, we're going to start by setting up our table. So we have our x, y table, and we're going to plug in our values and take the cube root of them. When we do that, we want to pick smart values. So really, we want to pick values that we're not going to end up with decimals. We want to pick positive and negative numbers because we can take positive cube roots and cube roots of negative values. So in my table, I would start with -8. The cube root of -8 is -2. I'll do -1. The cube root of -1 is -1. 0, the cube root of 0 is 0. 1, the cube root of 1 is 1. And 8, the cube root of 8 is 2. I'm going to use these values to graph my graph, and then later on I'm going to use these same values of this table in order to apply the transformations. So my first point is at -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. So what we're going to notice is this graph goes in both directions every time. It kind of looks like a flattened out S shape. That is the shape that we should have every single time when you graph these. Sometimes it will be a little bit more steep, or sometimes it will be a little bit flatter. When I go down to A here, I'm going to continue to use my same XY table. So I'm going to continue to start with -8, -1, 0, 1, and 8. The cube roots of those were -2, -1, 0, 1, and 2. From there, I'm going to look at my function. So we know everything like it was with the quadratics, like it was with our square roots. Everything inside the parentheses is always a horizontal transformation, and we always want to think the opposite. So the fact that I have a +2 in here means my graph is going to move left 2. To move my graph left 2, I'm going to have to subtract 2 from all of my x values. So when I make my new table, I subtract 2 from my x values, I get -10, -3, -2, -1, and a +6. Then the number on the outside is not being multiplied, so it's not a stretch, but we're adding 1. So that's a vertical shift. That's moving my graph up 1. To move my graph up 1, I have to add 1 to all my y values. So I get -1, 0, 1, 2, 3. This new table is going to be the graph of this transformation. So I'm going to graph this now. I'm at -10, -1, -3, 0, -2, 1, -1, 2, and then 6, 3. So for each graph, I'm always going to start out with my parent table. And then from that parent table, I'm going to apply the transformations that were given to me in the equation. So if I look at B, I'm again going to start with my parent table here. So I'm going to start with that xy. So I'm starting with -8, cube root of 8 is -2. -1, cube root of -1 is -1. 0, we get 0. 1, 1, 8, 2. Looking at my transformations in my equation. Instead of parentheses here, they just give us a root, but a root acts as our parentheses. So everything underneath there will always be my horizontal shift. So that -3 tells me that I'm moving right 3 this time. Remember, anything in the parentheses or underneath the root, we always think the opposite of. So for that, I'm going to take my x values and I'm going to add 3. So I get -5, 2, 3, 4, and 11. For my y values then, I have a +1 on the outside again. So again, that tells me I'm going up 1. So I'm going to add 1 to all my y values. So -1, 0, 1, 2, 3. Graph those values. So at -5, I'm at -1. At 2, I am at 0. 3, I'm at 1. 4, I'm at 2. And 11, I'm at 3. We're off the graph, but I like to just put a dot out approximately where it would be to help me when I connect the dots to get the right shape of that graph. Remember to include your arrows at both ends. So last but not least on C, again starting out with my parent function table, -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. My transformations horizontally inside this parentheses, I have the +5. So that tells me I'm moving left 5. So I'm going to subtract 5 from all of my x values. So I have -13, -6, -5, -4, and a +3. To my y values, this time I have a -1 on the outside, so that tells me I'm going down 1. So subtracting 1 from my y values, I have -3, -2, -1, 0, and 1. Graphing this then, at -13, I'm at -3. Again, I'm just going to put a point out here just to help myself guide the shape of that graph. At -6, I'm at -2. -5, we're at -1. -4, 0. And at 3, we're at a +1. Connecting my point, remember your arrows on both sides. And that is how we will graph our cube root functions. For target 5, we will continue to graph them, so I'm going to continue to do the same thing. The only thing we're adding here is the domain and range of the graph, and then the zeros. Remember, our zeros are our x-intercept. So we're looking for what our x-intercept is on the graph. So for all of these, again, let's start with our parent function table. So I have -8, -1, 0, 1, 8, -2, -1, 0, 1, 2. Applying my transformations to them then, inside I have -3, so that tells me I'm going right 3. So I need to add 3 to my x values. So I'm at -5, 2, 3, 4, and 11. To my y values, we have the +2 at the end, so up 2. So we get 0, 1, 2, 3, 4. Graphing that then, I'm at -5, 0, 2, 1, 3, 2, 4, 3, and 11, 4. Connect your points. So for my domain, remember your domain is your x values. We're looking how our graph goes from left to right. It goes from the left to forever to the right forever, hitting every single point. So I get all real numbers. Your range is your y values, so going up and down. This graph is slowly going down, but this side is going down. My right-hand side is going up, so my range here is also all real numbers. Our zeros, or we said were our x-intercepts. We have our x-intercept right here at -5, 0. So my zeros are at -5, 0. So on B, again, I'm going to base my graph off of my parent function. I don't have much room over there to write, so I'm just going to use the one that I already have there. Horizontally, my graph is moving to the right 2. So I know I need to add 2 to all the x values from that parent function table. So I have -6, 1, 2, 3, and 10. I have -1 on the outside, so that tells me I'm going down 1. So I have to subtract 1 from all of my y values in that parent function. So I have -3, -2, -1, 0, and 1. So at -6, I'm at -3. 1, we're at -2. 2 at -1, 3, 0, and 10, 1. When I look at the domain of this graph is also going to the left forever and going to the right forever. Every one of our cube root functions will always have a range of all real numbers because it will always go to the left and to the right forever. The same thing is true with our range. Our graph's always going to be going up forever. Our graph's always going to be going down forever. So our range is also all real numbers. Our 0, or our x-intercept here, is graphed at 3, 0. Always looking for your x-intercepts. Last but not least, we have c. So c, we're going to start with the same thing. Let's start with our parent function table. So we're at -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Looking at my transformations here, I have -4 underneath my cube root, so that tells me that I'm going to add 4 to all of my x values. So I get -4, 3, 4, 5, and 12. To my y values, so anything outside of that root, I have a +2. So that tells me to go up 2. So I have 0, 1, 2, 3, 4. Graphing that, we're at -4, 0. We're at 3, 1, 4, 2, 5, 3, oops, 5, 3, and 12, 4. Connect your points. Our graph again has a domain of all real numbers going to the left and right, a range of all real numbers going up and down, and then I have my x-intercept, or our 0, at -4, 0.